Okay, the screen has gotten somewhat cluttered. Should have made a bigger picture, and you should do so too when you draw these pictures. I should have known better. You have an excuse, I don't. Anyhow, we have 2 points. This point is 3, 5. This point is 11, 11. We connect the 2 points with a straight line segment, and that's going to form the hypotenuse of a triangle whose 2 legs are parallel to the 2 coordinate axes. Now, I said originally that if we start from this point, we can do our first leg from this point either in the horizontal or the vertical direction. Okay, I'd let the class choose, and somebody chose vertical, so right here is the first leg. The second leg is going to have to go through this point. We can't draw another leg of a triangle with this hypotenuse through this point. If we draw a leg here, it's not going to be part of the same triangle. So we have to draw the leg through this point, and that's not going to have to be horizontal because another vertical leg is never going to meet up with this vertical leg. So we have no choice. We've got to go horizontal, and then we get these 2 green segments for the legs of the triangle whose hypotenuse runs from the first point to the second. Now, we ask a number of questions. First of all, what are the sides? What are the lengths of these legs? Okay, well, it's very clear that this leg rises from vertical coordinate 5 to vertical coordinate 11, and that's a rise of 6. And that's indicated up here from 5 to 11, the rise is 6. And from horizontal coordinate 3 to horizontal coordinate 11, the run is 8. So we have legs of 6 and 8. Then the question is, how long is the hypotenuse of that triangle? Well, we can use the Pythagorean theorem. We have a right triangle, we have the 2 legs, we can find the hypotenuse. And it's just going to be the square root of a squared plus b squared is the way you usually say it. And somebody said, well, rise squared plus run squared, and that's absolutely correct because the rise is one of these legs and the run is the other. So we have a squared plus b squared, 6 squared plus 8 squared, which gives us 36 and 64 under the radical, which adds up to 100, the square root of which is 10. So the distance between the points is seen to be 10. So, what else? Well, what's the slope of the original segment? Okay, the slope of this segment, the segment that joins these 2 points. Well, what do you know about slope? Well, slope is rise divided by run. So slope is rise divided by run. The rise is 6, the run is 8, the slope is 6 divided by 8, which is 3/4, or in decimals, 0.75. My point is then that the picture of this triangle gives us both an easy way to calculate the length and an easy way to calculate the slope, and they both depend on this triangle. You could have equally easily have drawn the triangle from here to here and up, down below the hypotenuse, but it's valid either way. Now, if I apologize, that last sentence started nothing because I thought I was doing something else. I had to look back at the question to see what question was being answered here. It's not what I thought it was going to be. Okay, and of course I remember now. You're asked to find the point in the middle of this segment. So right there is a point representing the middle of the segment, and then to construct the triangle from whose hypotenuse runs from the 3, 5 point to that midpoint. Well, if you construct the triangle with sides parallel to the coordinate axes, it's going to look like this. And the question is, what's the run and what's the rise? Well, of course, you see them labeled here, but how do we get a run of 4 and a rise of 3? Well, if this is the midpoint, then this distance should be half this distance. And if this distance is half this distance, since the triangles are similar, this triangle here and this triangle here are similar, corresponding sides are going to be in the same proportion, so that the vertical side is going to be half vertical side of the smaller triangle is going to be half the vertical side of the larger, and the horizontal side of the smaller will be half the horizontal side of the larger. So we're going to have legs of 4 and 3. Now, using those legs, we can figure out what the coordinates of this midpoint are. Okay, starting at 3, 5, we move horizontally 4 units. Well, we started at horizontal coordinate 3, we move 4 units, and we reach horizontal coordinate 7. So the x-coordinate of this midpoint here is going to be 7. So that's represented by the 3 plus the 4. 3 here plus the 4, we move from here to here. And then the 5, which is the vertical coordinate where we start here, we add 3 and we get to the vertical coordinate of this point. And that's going to be 5 plus 3, or 8. So the midpoint is 7, 8. Now there's another easy way we could have done that. What's halfway between the horizontal coordinates 3 and 11? Well, we can add 3 and 11, we get 14, divide by 2, we get 7. That's the midpoint between these two coordinates. The midpoint between 5 and 11, the vertical coordinates of these 2 points, is again halfway between, and that's 8. So 5 plus 11 over 2 is 8, and then again we have the coordinates of our midpoint. My big point is that you don't need formulas to calculate these things. All you need is a picture. So we have this picture, and from this picture we can label these triangles, and we can figure out the slope, the distance between the points, and the midpoint. Another thing you were asked to do is use the Pythagorean theorem to reinforce your conclusion that this is the midpoint. You're not actually going to prove it, but you're going to reinforce it, okay? So we're trying to find this red segment, this hypotenuse. Well, the legs are 3 and 4, so the Pythagorean theorem says that this red segment is going to have length square root of 4 squared plus 3 squared. If you work that out, you get 5. And that is half the length of the original segment. Remember, that length was 10. So that reinforces your belief that you've correctly found the midpoint, or that you've at least correctly located it. Now, as far as formulas go, well, we'll talk about that, but I'll do a separate video.